Italian National Support Service. I'm Giulia. I'm not the person you are seeing in through the webcam, but I'm next to our expert who will talk during this session. So this webinar is organized by the Italian National Support Service together with our colleagues from the Central Support Service of eTwinning. And I thank Assi for her help. And I, of course, thank our expert, Professor Formiconi, who's going to talk. Professor Formiconi works at the University of Florence. He will tell you more about his work, and he's responsible for the TTI project of eTwinning at the University of Florence. So we work much with him about this topic. So before Professor Formiconi starts talking, I would like to share with you in the chat of this webinar the link, a link to the Google Doc we have created. This Google Doc contains some links that Professor Formiconi will tell you more about them. And also you can use this Google Doc to write down questions if you have any. And at the end of his speech presentation, the professor will try to answer at least to some of them. So thanks for your attention and enjoy.
So thank you, Giulia, for the presentation. Welcome to this to the first of two webinars, A Step Back into the Future. As it has been told by Giulia, my name is Andreas Robert Formiconi, and I'm with the Department of Statistics, Computer Science and Applications of the University of Florence. Among my activities, the one which is related to these events is the fact that I'm actually in charge of the eTwinning teacher training project for the University of Florence. And the fact that I'm teaching to some 300 student teachers in the 50 years of the primary education curriculum. Something that is called Laboratorio di Tecnologie Didattiche, Laboratory of Technologies for Education, basically. My background is in physics. First of all, let's have a view of the plan of this of the talk of today. We are going to focus a little bit on the free software concept, and specifically one kind of free software, because we will use it, is LibreOffice. Is an office suite akin to the well-known Microsoft Office, and a plugin of this program, which is called LibreLogo, which is an implementation of the Logo language. Then we will focus on what actually we mean with the expression "a step back." Then we will try to get an idea of what means turtle geometry, because turtle geometry is the geometry actually of Logo. And we will try to explain why it is a true geometry, it's not a game, despite the name. And then we try to focus the concept of body syntonic learning that we owe to Seymour Papert. we tell some words about this great scholar. And then we try to see some basic Tartar coding constructs. We will try to go and have a look to some true coding experiments. Let's have a very briefly look to the plan of the next talk, which will take place next Friday, next week. We will try to explain a little bit better what does it mean. What does mean this famous sentence of Seymour Papert that a language for education should have a low floor but a high ceiling as well. We will try to comment a little bit on math and beauty, that is reasoning, but also allow ourselves to appreciate beauty, because the two things actually are related in order to be truly creative. And then we will try to go to see some application, or we will go in some depth of a few aspects. That is the concept of infinitesimal spirals. We will discover that turtle actually is really an animal, maybe an animal, and the beautiful world of fractals. And the fact that with such a simple device as LibreLogo, the software instruments, it is possible also to simulate some physics experiments. And we can also try to simulate the movement of body in space, such as the Halley comet. This is to explain the vertical dimension of an instrument of this kind, going actually from a low floor to a really high ceiling. So let's go. When one has to talk of free software, of course, has to talk about Richard Matthew Stallman. He has more or less my age. I'm 63. I believe he's 65 now. He, in the 70s, he was a brilliant researcher at MIT, Artificial Intelligence Laboratory of the MIT, Massachusetts Institute of Technology. He's a physicist as well. And he was an extremely brilliant programmer of computers. But in those times, I mean, more or less at the end of the 70s, he was discovering that software was becoming a crucial, a strategic element of technical instrumentation, and not just a final refinement. This is demonstrated by the fact that all of a sudden, all over the world, pure software companies emerged. The most important, most famous perhaps is Microsoft Corporation. But what is actually free software? Free software is characterized by 4 essential freedoms. The first one is the freedom to run the program as you wish for any purpose. Then the freedom to study how the program works and change it so it does your computing as you wish. This means that you can read what the program does. That is, you have the so-called source code of the program. As you well know, usually if you buy a software, you can't read the instruction of the software. You can just use it. This is proprietary software, and this in contrast to free software. To get the free software means to get the software that you can run, but also the software that you can read, to understand how this program is achieving the results that you are seeing. Third freedom is the freedom to redistribute copies so you can help your neighbor. And the fourth freedom is the freedom to distribute copies of your modified versions to others. Freedom 3, actually. By doing this, you can give the whole community a chance to benefit from your changes. I want to emphasize two statements here. In Freedom 3, so you can help your neighbor. And in Freedom 4, by doing this, you can give the whole community a chance to benefit from your changes. What I want to emphasize is the fact this is purely technical matter. Huh? We are talking about technology, we are talking about software, programs, and suddenly you find these states. These two statements are not technical statements. These are ethical statements. And this is what makes the difference of free software with respect to all the other kind of software, even the open source. Open source software is distributed with the source code readable as well, but it has nothing to do with these characteristics. Open source may be produced by a company that finds useful for their marketing purposes to give away in the free community some source code. And that's okay, it's not bad, but it's different. Here we write and use free software because we have something else in mind. We believe in the benefits of helping others and the community. This is important to take in mind. There are really many popular free software programs. Well, you can decide that your computer runs a whole operating system in free software. This is the Linux free software. Otherwise, and this is important to understand, you can run specific programs that can be downloaded and installed in all the operating system. For instance, LibreOffice can be downloaded and installed in Linux, as well as in Windows, as well as in Mac OS X system. LibreOffice, we have already said, is an office program suite like Microsoft Office, similar. Then you have GIMP, just to have an idea, very shortly, which is, pardon me for the mistake, a bitmap image manipulation system with a power similar, functionalities similar to Photoshop. Then you have Inkscape, which is devoted to the manipulation of vector images. Then there is Audacity, which is a software for audio recording and processing. Then OBS, video streaming and recording. And Shotcut is one of the available examples of video cutting software, just to have a broad view. I want to give you an idea how, because the idea of Stallman, he developed his idea mainly in the 80s by giving birth to the so-called Free Software Foundation. Exploded from 92 with a software which at the beginning was written by Linus Torvald, a young student of informatics in the University of Helsinki. And since then, you see how many versions, so-called distributions of Linux you have. You can all these versions may be downloaded and installed in your computer. There are families. The most important is Debian, perhaps, and then one of the sons of Debian is Ubuntu. Ubuntu is the distribution that is more easily usable for people that are coming for commercial system. But I wanted just to give you an idea. I don't want to spend so much time here. You can explore later on. why free software is good at school. This is a crucial point, and that's why I'm spending with you some time about this subject. Free software is good at school because you are implicitly teaching the value of collaboration, because free software is usually written by a team of people and very loosely connected around the world. Free software is truly about collaboration and also cooperation. You are implicitly teaching that to do something for other people is good. This is good to teach at school. That to crack proprietary software is bad because it is against the law. Better using free software so that you are helping the developers communities as well. More users mean better software, as it is well known. And you are implicitly teaching that free software is something for everybody and not only for those that can afford it. That's very important for public schools. Europe is a large set of countries. There are very large differences, and not all the populations has the same possibilities. If we are talking about public schools, this is a very important fact. It is also important that we build models where the hero is not someone that made a lot of money, which is not bad in itself, but also to appreciate people that have done so much for the community without asking nothing in terms of money. This is a good message for young people. Well, LibreOffice presents itself that way. It is a word processor. You can guess it by looking at the usual formatting, very easily understandable formatting icons. And yes, I want to emphasize at once that there is a fancy toolbar here. What's that? This is the LibreLogo toolbar. So when you download and you install LibreOffice for the first time, you don't see the first time this toolbar. You have to go, first of all, to activate this plugin, which is actually embedded in LibreOffice, by going in View, and then Toolbars, and then Logo. And you have to check the logo. At this point, be aware of the fact that this makes not appear the toolbar appear. Remember to exit the program and relaunch it. Let's go to have a look to LibreOffice Alive, I would say. Here we are. So you see, this is the LibreLogo toolbar. Well, I want to show at once what does it mean, low floor, and how basically works the coding process in LibreLogo. I must say that this is due to a genial idea of a computer scientist of Hungary, which is called Laszlo Nemeth. I'm in touch with him. Sometimes we exchange idea. That's a beautiful aspect of free software. You see, I can write to the author of the software and we can talk about to learn better and to improve it. So you see, at once cooperation alive, I would say. So let me write something. Forward. And I put a number. So that's not amazing. This is a word process. Why should not be able to write something? But of course, you understand, all of you understand the meaning of these forwards. But this is not an English statement. It's not very nice. And there is a number. Of course, you also understand. You can guess something. Well, this in Logo is a line of code. how it works to code in LibreLogo? Well, you write instructions and then you click on the play arrow, on the green arrow, which means play, is a play button. Well, something happened. A stylized turtle appeared and also a segment. Let us try to understand what's going on here. So you have at once an idea of the coding. I write another instruction, which is sleep 3000. What does it mean? It means that I am telling to the turtle to sleep for 3000 what? 3000, the turtle understands milliseconds. So I'm saying, please turtle, sleep for 3000 milliseconds, which doesn't mean sleep for 3 seconds. And then execute what follow, which is forward 100. If we let run this version of the program, pardon me. First of all, I have to get rid of what was here. I cancel the page, okay? Then I start it again. The turtle appeared, but she's waiting 3 seconds, you see? And then executed this line of code, which means go ahead for 100 points of the page, drawing what turns out to be a segment, because I just telling you to go straight forward. So this is basically the way you're coding. So let's get rid of this sleeping instruction, and I write something without telling you, because of course you can very easily understand it. Right? Pardon me. Right? 90. Let us try. I cancel the page, and then go home, and then go. The turtle drew 100 point segments and then turns herself by 90 degrees, which is not surprising. So you may decide, oh, that's nice. Why not go on and try to draw a figure? Well, in that way you understand how easy it is to code by means of manipulation of text. I copy this and then paste. Oh no, that's wrong. I didn't copy it. Okay. Copy. Then paste, paste, paste. Adjust a little bit. Okay. Well, if I cancel, I erase the page, go home, and go on. We have a square. That's the way we produce drawings in Logo, in the LibreLogo version. So in the same page, you have the code that you adjust, and you have you produce a graphics which can be manipulated with the graphics options of the right components of LibreOffice. Even the turtle is the graphic object, and if you like, you can work with this. So this is the very extremely low floor of LibreLogo. It's very easy to bring someone, even a kid, in this environment, and let's begin to see what the turtle can do for us. So if we go back, and we go on, now let's focus on a step back. A step back, what actually I mean? I mean substantially two things. First of all, to recover a paper's thoughts about coding as a practice to improve math learning, which was the way that the coding at school began, but now with so large offer of instruments and software devices and methods, even very powerful, very nice, this has been some way forgotten. And second, yes, but I mean, block programming a la Scratch may be fine. However, the power of text shouldn't be forgotten. Briefly, what I mean with Scratch, I think all of you know, because it's very popular in education. At any rate, if I'm going in Scratch, just to remind you, okay. I go in my space. Okay, and I go to my stuff. Here we are. I take randomly something. Click here to enable the awful Flash player. So you know that I don't like very much Flash player. Okay, and then we should see a kind of silly game. The helicopter is falling down by itself, but I can manage to move it. That's very silly. Just to demonstrate something. In Scratch, you are in a social environment because you can go and see what other made. You can remix their project, and you can make them your own. You can share it again with the community, which is what you actually are encouraged to do. And you can go inside to see what's going on. Where, for instance, what is the code that is moving the helicopter? This is the code. The code in blocks coding system is reliable means of blocks, colored blocks, and the color has to do to categories of instructions. The instructions can be easily dragged in the coding space and can be combined together in some way, making the syntax, the application of syntax rule easier, and you don't have the risk to make orthography wrong, because actually you have not to write instruction, but you have to drag code. Of course, this has been imagined for a number of reasons. Also, the reason to make easier and more nice for kids that are so used nowadays to graphical interfaces, clicking and dragging stuff, and this is also thought to make video games possible, the building of video games possible. I must say that Scratch is not in contrast to Logo, but is the son of Logo, because Scratch was developed in its first times by Seymour Papert itself, with a collaboration with one of his former students, Mitchell Resnick. So it's not a contrast, but it's a kind of evolution. This is true. And what you can do in Logo, you can do even in Scratch. That must be said, but with a much richer possibilities. So let's go back to our talk. So let's go on. What I want to do is to share with you a mood. I wrote here feeling, perhaps it's better to say mood, don't know. At any rate, I don't succeed, but I want to try to share with you this mood, to understand the basic reasons of what we are talking about. You see, these are the hands of men, specifically my hands, but this is irrelevant. And I want to comment with you that this is the position where your creativity has the maximum of potential. You in front of a blank, of a white page with something to write on it. You are in power. You are the master here. Everything is up to you. There is nothing else in the middle. Probably what I was going to do here, probably I was trying to write a shopping list to go to the supermarket this afternoon and buy something to eat this evening. Or maybe I'm beginning to write a dear friend, a letter to a friend, or I'm trying to jot down some numbers to make a calculation. Why not beginning a novel? Or maybe a poem? Why not a poem in German? Well, I know a little bit of German, but not so much to write a poem. This is a limit, that's true, but this is my limit, and I'm in power about that limit. If I want, I push that limit as much as I want. I can decide that starting with tomorrow, every hour in the afternoon, 1 hour every afternoon, I study German, improve my German. And perhaps in 6 months, I'm able to write simple poem. It's up to me. There is no one else in the middle. And there is no interface here, no button that someone provided for me, implicitly telling me what I can do and how I can do it. Of course, these instruments are beautiful because they make my life easier very often. They empower me in some sense, but they always hamper in some way my freedom. That must be always taken in mind. I hope that that you understand the mood that I'm referring to. On the basis of this, let's try to comment on a comparison between blocks and text-based coding. So basically, here you see the codes we have written just a moment before. Well, there is something more. I can put here, because it's a nuisance to erase always the page, I can put here clear screen. Oh, pardon me. It is irrelevant here to use uppercase or lowercase, but I think it's more readable for you. Clear screen, if possible without errors. And then I can say to the turtle, after having erased the page, go home, which means go in the middle and with a nose up. This is important. We will come back on this concept. So if I run this program, I draw a new square on a blank page. So this is the code here. There is something more. I make sure that the pen is down, because I can also move the turtle without letting her draw, and I can then write pen up, maybe to go somewhere else, and I can say, please hidden yourself, my dear turtle, and I can write hide turtle. So this is, you see, this is exactly the code we have here, and this is the correspondent version we own blocks. You can recognize all the instruction, every instruction, clear screen, pen down. The way to say the turtle or the cat in the case, or whatever, it depends on the costume you use in Scratch, to go home, is to set the x coordinate to 0, which is in the middle of the page, set y to 0, and point in direction 90 with a reference system convention of Scratch, which means nose up. This is all. Then move 50 steps is forward 50. Turn right 90 degrees is right 90, and so on and so on and so on. And then pen up and then hide. The result is exactly the same. So you see, you can do the same thing. I show this example to be sure that everybody understands what are we talking about. Now, pardon me, because it's not nice to show crowded slides. I understand. But I wrote this because I will leave this material to you so that you can go back and see better. Now, please follow what I'm reading. These are papers, scientific papers. What I want to show with this paper is that the educational advantages of using blocks-based programming are not so clear. There are advantages, but there are also disadvantages. This is what the scientific studies tell us. I'm so sharp in pointing out this because there is also, as it is usual nowadays, a kind of fashion, so that it seems that coding, computational thinking, and so on, is maybe for many people just scratch and block and block programming. This is not true. From this study of Weintraub and Wilensky, you can find it in the internet and download. I extracted this sentence. Learners get gains from the affordances of the block-based modalities for the understanding of specific constructs, but not for slightly more challenging comprehension tasks. What does it mean? Now we are going to see what we mean by means of constructs, a particular combination of instructions. So if the problem is to understand the meaning of the specific constructs, it appears that blocks-based modalities are better. But this is not so true when we are proposing to a kid a program. We are asking what this program does. Then this is a higher cognitive task. Then the advantage is no more so clear. Again, from Weintraub and Wilensky, we have these studies which was made to get the perspective of the students. And they conclude that students generally find blocks-based programming to be easier than text-based alternative, but also identify drawbacks to the blocks-based approach, which means authenticity, expressive power, challenges in authoring more sophisticated projects. This is one typical sentence told by a boy or the girl, I don't know, pardon me. With text-based programming, you can do a lot more. Blocks are limiting, like you can't do everything you can with Java, I guess. Excuse me. Java is one of the many, I would say, regular languages that are hanging around. So usually at the beginning they appreciate the very easy and nice Scratch interface or similar. There are other environments such as Snap, Alice, and so on. But as soon as the kids become more proficient, they begin to feel limits in the process, and they begin to feel less free. Another study by Lewis, Colin at the Berkeley University, how programming environments shape perception, learning, and goals, Logo versus Scratch. She concluded that students that learn Scratch had greater ability to interpret conditional statements, not so much interpreting loops, and on the contrary, students that had learned Logo had an average higher confidence in their ability to program. So this is a result which is in some way similar to the first we mentioned from Weintraub and Wilensky. I want just to say or to tell you with these examples that the scenario is complex, is not so clear, presents not so clear advantage for one method instead of another. But back to text, therefore, no, but do not forget the power of text. Briefly, orthography. Well, very often it's said that, well, but with blogs, kids have not to bother with orthography. But is this really an advantage from an educational point of view? I'm asking you. On one side, when they are making their English lesson, we are very strong in requiring that the syntax is correct. And then all of a sudden, when they go in the coding class, they have to forget orthography. Why not take advantage the concept of orthography and the necessity of a correct orthography in two different environments, taking advantage in crossing these differences. The same said for syntax. English, this I said for non-English speaking people. Very often in Italy, people tell me, oh, but logo is in Italian. It must say that it can be also put with instruction in Italian, but I'm answering always. But the grammar of logo is composed by a really small number of words. You can do incredible complex things with a few instructions. Are we really saying that it is a problem to use 4 or 5 or 6 or even 10 words in English? Are we teaching or no English in the English class to these people? Why not take advantage of the both things together? Then, speed when competencies grow. I show you how easy it is how easy it is to edit code here. You are very fast. You cannot be as fast in a point-and-click interface. At the beginning, you enjoy it. When you have complex things to manage, you get tired. Sharing text is extremely easy. You see, I can copy this, paste in an email message or the blog post or forum post and wrote it and post it for everybody. Text is the most easily thing to exchange. It's true that Scratch is conceived as a social system, but is closed in the sense that it's not so easy to exchange these blocks. Yes, you can download it as files, and you can, if you are a little bit a hacker guy, you discover that you can explode as a zip file, and that inside you have JavaScript code, which is fairly complex. But this is not so easy to exchange, in the sense you can exchange, but within Scratch. If once Scratch will disappear, all of this will disappear. Text is forever. Accessibility. Well, Scratch has a downloadable version, but it has limitation. Usually the full power of Scratch is achievable through access to what actually is a web service. But you need a connection. Now, in many countries, the broadband connection are not granted at all, beginning with Italy. There are many, the majority of schools have not proper connections to let the kids work freely with a web service. If you work in LibreLogo, you work locally. You can open your laptop in the train and work without problems, without connection, or on the top of a mountain or whatever. And students crave hard. students like to do as the adults do. They get tired easily of toys. It is much more nice to try to drive the mother's or daddy's car than to drive a toy car. All of you know very well this. Let's go back to Simon Papert for a while. Simon Papert was a mathematician and from South Africa, but for 4 years he worked with Jean Piaget, I believe between 1958 and 62. He was born on 1928 and he passed away on 2016, a couple of years ago. And he was a mathematician, a pedagogist, and a computer scientist, and with a very broad cultural and a very fascinating broad view of education. He was telling us that the software language should have a low floor and a high ceiling. By the way, this thing is actually what is known as a D-bot, one of those robots to code very easily. And Logo began that way. Afterwards, became a software program. And some thoughts of papers about Logo. Logo was intended to be more than a programming language, but the catalyst for the generation of learning and teaching culture, which entails children's interaction with others, child teacher, beyond child computer. With Logo, you learn to program a computer. However, not just to learn programming. Of course, you do as well in some basic ways. But you learn to think and to reflect on your own thinking. For instance, by means of a positive attitude towards errors. This vision is common with Scratch, of course, or other similar environments. Scratch is the son of Logo, after all, as we have already said. However, the basic motivation of Logo and related languages as means for improving learning math has been largely forgotten, and we think that we should go back one step back, because this is the basics of coding. After all, coding is a branch of math, and the problem of teaching math is still a problem almost everywhere. There are some findings from the literature, but since you will have this material available, I let it just to you, because I want to spare time for something else as well. In this case, I only say that letting children using Scratch, Logo, or whatever doesn't mean just exposing them to this environment. The teacher has to be there and to provide the scaffolding, trying to connect the intuitive math with the formal math teacher are trying to teach them. You can go to this paper when you have time and when you like. Now, Tartar geometry. Tartar geometry seems a joke, but it's not. Harold Abelson and Andrea Di Sessa wrote an almost 500 math book full of theory. Just to mention a fact, the last chapters are devoted to simulate the general relativity theory on the page where the tartar is moving, just to give you an idea. I want to show you briefly what does it mean to say that the tartar geometry is a geometry. Well, Of course, a true geometry is Euclidean geometry. A point is an dimensionless entity in Euclidean geometry. That's all. In Cartesian geometry, focus is on the coordinates that characterize this point. 2 coordinates if you are in the plane, 3 coordinates if you are in space. In Tartar geometry, instead of the point, you have the position of the tartar, which of course has a point, but has also a direction. You have, so, where the tartar is and where there is no hair, I don't know, is hair or his, I don't know. Well, hair, nose is pointing. This gives rise, talking with Paper Lessico, a powerful idea. The idea of state. The idea of state of a system is a crucial idea in math and physics, engineering, chemistry, and so on. So the state of tartar is characterized by her position and the direction where she is pointing. Then you will tell me if in English the tartar is she or he. Actually, in this moment, I don't know. A square, I don't spend more than a Euclidean perspective. In Cartesian perspective, is given by 4 couple of coordinates with this shape. You have the same y in the low points, the same x along the vertical side. In the Tartar geometry, a square is a piece of code. This is really important because an important point to understand is that in mathematics, mathematical object can be of any kind, can even be piece of code. Abelson Disessa wrote several theorems that are dealing with mathematical objects that are just pieces of code. We will come back to this piece of code. Let's go on now. And then again, a circle is the place of points that have the same distance from a given point, which turns out to be the center. And in Cartesian, this is just an equation which expresses the theorem of Pythagoras. X to 2 plus y to 2 is equal to the radius to 2. In Tartar geometry is something very simple of this kind. Now, a crucial concept, crucial papers concept in the low floor vision of coding that is for kids, the body syntonic learning. What does it mean? This means that you take advantage to the natural geometry knowledge that kids have before they come to school, to move in space substantially and to deal with objects in everyday life, and to associate the movements of their body to movements of something in another space. It may be a robot, it may be a turtle, it may be a mathematical object. This picture is due to an experimentation that a teacher in North Italy from Paderno d'Adda, near Lecco, near Milano, Antonella Colombo, gave me always a thanks. I thanks a lot, Antonella. So you are trying to let the children move on something that is a circle. This is the code, logo code that produces a circle. I drew that way. And you see that it means repeating several times, actually at infinity, two instructions. Go forward one step, that is a very small step, and turn left or right, it's the same, 1 degree, or a very small angle. And the body syntonic concept is realized by this very nice picture of the legs of this girl. You see that she is making one small step, which is forward one, but she also provides to turn her feet a little bit, which is left. So they experience with their body what they will try to code. This is body syntonic learning. These are other activities they perform. This is my friend, teacher Antonella Colombo in primary school. So how carefully the kids are trying to follow this path. Then they they spread sunflower on the floor, and they try to move themselves, reproducing a circle, and see if they succeeded. So reflecting how to do things in order to get the circle. This is body syntonic learning. And then trying to extrude in some way what they experience in their mind towards something external, that is a small figure, and how to move, for instance, forward, right, and so on. And then go to coding. Now, Tartar commands may be to make a very rich experience starting from a body syntonic view with a very few commands. Actually, you could do almost everything with forward and right, because to go back, you can write -10 here, and you can change the angle, and you can change to minus to go left. But there are instructions that make young children life easier. That is, you have the left instruction and you have the also back instruction. With these are called so-called state-changing commands, because also in Logo you have a fairly large number of commands, but these are the basic that act on the state of Tartar. What does it mean? It means that if I execute a forward, I change the state of the Tartar, in the sense that I change her position, not the direction. If I executing a right or left instruction, I'm changing the state of the Tartar, in the sense that I'm changing where she is pointing her nose, but not their position. This is a crucial step to work on with children so that they disassociate these two different variations, geometrical variation. This is fundamental to get right into the world of angles, for instance. Now, I try to describe you the basic software constructs you can use in Logo, but I tell you that these are the very basic software constructs of all language out there. C, C++, Java, JavaScript, whatever. They all have these kind of structures. Python and so on, realized in a way or in another. But they extremely simplified syntax of logo is ideal to get people understand, grasp in the essence what these constructs are, without to have to bother with the fuss of fancy, strange syntax. Too many brackets, and curly, square, round, point, columns, semicolon, and so on, which characterizes many languages. Or fancy management of spaces, such as Python. Logo has very, very, very simple constructs. Now, for a while, I'm describing you here cycles. You may have the necessity to repeat a bunch of instructions. Well, why not go back to our picture here? So you see that you have a scheme, a pattern that is repeated. Well, we can experiment it once. I put here a so-called repeat instruction. I begin the sequence of instruction that I want to repeat by means of a square instruction. Let me enlarge a little bit. And then I close with a closing square brackets this sequence. Oh, pardon me. Okay. Now let's try to run this code. I made, oh, pardon me, I made I hide the turtle. Oh, let's make sure that the turtle is shown. Show turtle. Okay, now go. The turtle is drawing a square, but she keeps drawing it. What's going on here? Well, if you find yourself trapped in a situation like that in LibreLogo, go to the red button and stop it. If focus is on the graphics of the turtle, just get rid of them with the backspace. We made a repeat, but we didn't specify how many times. Well, we can tell the turtle easily also this. Please, turtle, do this 4 times. Let's go. Thank you, turtle. That's okay. So you see how you produce a repeat construct. Then you have encapsulating. We will look at that later on. This is produced by a sequence of instructions where you have a to in red and an and. And then in green there is the name you want to give, to a set of instructions. This means that, no, it's better, I prefer to show you at once. Let's do that way. I write to, and I give a name to this procedure, SQU, for instance, which says, if you want, for square. Yes, we are now, thank you. And then end. Now, I get rid of this instruction, and I cancel the page, and I let go. The turtle appeared, but nothing happened. Well, what's going on here? When you begin a code like that with to and a name you want to give to this set of instruction, means that you are saying to the turtle, my dear turtle, yes, please sit down and listen to me what I'm saying to you. And memorize, please, learn the commands I'm giving to you, till you encounter the end instruction. When the turtle finds the end instruction, she begins to be ready to move again. So if I execute this code, of course, nothing happens. How to activate this? Well, I defined a new instruction. This is the way you can enrich your language. In Logo, there is not such an instruction. Well, just do that way. Go. You see? Now, from to end, the turtle listened to me, and when I asked it to execute the new SQU procedure, she did it. This is the way you can expand in a very extremely powerful language. Now, I wanted to talk about an hour, and I got the idea to interrupt myself, perhaps giving you the possibility to discuss a little bit. But I leave the choice to you. I can go ahead describing also these constructs and then discussing afterwards if you're not too tired, or I can try to answer to your questions eventually. What do you think? And Julia also.
Yes, thanks, Professor Formiconi. So we shared the Google Docs link with the participants, and some of them have written some questions. So I don't know if you want to see them and answer to some of them, or it's up to you. If you want to talk for some more 10 minutes maybe and then answer the questions, you decide. We will end at 6:30. So you have 25 minutes more.
Here I have my microphone on.
Yes.
I see there are just no, not a couple of questions. Well, this is a complex question. How teach Italian? How can I use the tools you have illustrated? Well, to use these tools is very easy, in the sense you have to go to look in the internet with Google. For LibreOffice, you find it once, you download it for your system, you install it, and you are on. That's all. How can we relate these tools with language teaching? This is a complex question, because basic teaching Logo, a basic software teaching with a language is very good for teaching, or for easing the teaching of math. Teaching of language is more, I would say, indirect. In the sense you are pushed to good reasoning, and that's good. You are pushed to writing things in a correct way. You are forced to take extremely care of orthography, because just one letter wrong makes things not work. You have to be aware of syntax, because there are ways the instructions are linked each other. But if you mean to make exercise related to construction of English sentences, etc., there are examples. It is possible to do things like that, but this requires more complex programming, which is more on the high ceiling instead of on the low floor side. And then I clear screen. How can we integrate the tools to our lessons you have explained us? How can we use these in our projects? But this has to do to works that you can do with your kids. Of course, you have to have access to computers. Kids have to access computers. And then you let kids work in teams, because this is what also Papert intended. It's very good to learn to work together. 2 or 3 or even 4 boys work very well, because one is writing, the other are reading, they get idea, they correct each other. This is a beautiful tool to teach collaboration. For me, the approach to coding is similar to CLI, which teaches a vehicular language. Yes, maybe. Do you think that use some kind of Tartar geometry could help students complete an artwork in cooperation? Yes, I'm letting hundreds of teacher students working, and they very often apply what I'm learning with me. They situate it once in their trainship experience, and actually very often it turns out that they are using Logo to produce pieces of art. Maybe I will show you something in the next webinar about that. After all our communication here is programmed. Thank you very much for everything. I think you already answered in a way. It's okay. Do you think we could create performance after logo drawing and inspire children to combine art and expression and communication? I think so. I will reflect on this during this week. And then there is someone making a proposal. Yes, please go and write. You see, guys, how easily natural is for you to putting pieces of code in text and for sharing with others. Well, I want to try it once. I take this, I go in my Logo here, I open another documents, and I try to run your code at once. That's fun, I must say. Oh, thank you. This is art as well. You are answering by yourselves in a way, isn't it? And then, well, we could go on. I answered the first bunch. I tried to answer to the first bunch of questions. Pardon me. I go now back to my presentation, and I'm trying to go on. So we had a look to repeating, how to repeat groups of instructions, encapsulating, how to tell the turtle to make in a row a set of instructions. So a powerful generalizing instruments, but with the concept of generalization, you have also the concept of variables. That is, you can define variables very much like as you do in algebra class. I take a variable, I give her the name A, and I put A equal to 3.14. This is an open towards algebra. Then there is the fascinating world of infinite, which is realized by means of a very powerful concept of computer science, which is called recursion. This is based on the procedure concept. It is realized in the very basic, the most basic way, by defining, as before, a procedure with procedure name as name, and ending with whatever instruction inside, but also a procedure name instruction. What does it mean? Well, I think it's worthwhile to go in real world. Well, let's close the heavy window of Scratch, because heavy things are not good for computers. So let's go here, and first of all, let's go on this construct by applying. No, we have already applied it actually. The concept of procedure to the drawing of a square, as you remember, and now we are doing something strange. So this is, I use indenting to facilitate you in reading the code. This is a very, very good practice. It's not mandatory in Logo, but it's good because you read better. Simplicity and tricks to make things clear are always welcome, not only in coding, but in math and perhaps in general thinking. So, and we can also use indenting to have clear what's inside the repeat and what's inside the definition of a procedure. So this is already familiar to us. Let's make something. Well, first step, we told about variables. Variables are very useful in procedure. I could say to the turtle, please, my dear turtle, I'm going to teach you a new command which is called SQI, which needs a variable, and the name of the variable is side. Of course, when I'm teaching the single instructions to the turtle, I have to mention where side has to be used. So the turtle knows that when she will be asked to execute AskU, she will be given a number, and she will be supposed to use this number here, in this place. When we are asking the turtle to execute this code, we have to give her a number. So the Tartar will know that when she has to execute SQU, she has to substitute side with 100, and she will execute a forward with 100 points. Let's see if this is true. Nome sconosciuto, that's not know. Where? What was wrong here? That's the beauty of code. SQU and SQU. That's fancy. Okay. She did what she was expected. We can now appreciate the generality we have achieved with the concept of variable. Because if I want to draw suddenly a 20-point sided square, is that easy? Is this nice or not? Or a 200, because kids like to exaggerate. Oh, that's really nice. I can insist because I'm a kid and I get amused by this stuff. I go on. 20. Oh, please don't make mistakes, Andrea. Okay. Oh, boys. You see? I'm excited. I'm a boy. Okay. Here we are. No, what's that formula? I don't want the formula, please. That was not foreseen. Please go away. Please go away. Thank you very much. Okay, then. Okay, you can play around with this. Now let's go on. Let's go on. Go back with this basic construct, and we make another step. I'm putting here a strange instruction. I'm telling you. I'm telling you. I get rid of the repeat. Oh, that's a surprise. I get rid of the repeat. And of course, if I execute this, I just draw one side and I turn. This is not new. It seems that this was really a silly step. We went a step back. I am the step back guy, actually. Well, let's make another step by writing here SQU, SQU side. Well, you could say, Andreas, you made another silly step, or perhaps better said a mad step, because you are defining a procedure and you are calling the procedure inside the procedure itself. That's mad. Yes, but perhaps madness is the way to creativity. You see, we are drawing a square, but the turtle is skipping going on. Well, stop, please. What's going on here? Well, this is recursion. This is recursion. That is, go back to the presentation. You have here, you call the procedure name, but inside the procedure, you call the procedure name, giving rise to another process which will call procedure name again, and again, and again, and again. This is the way to go to infinity. That's why the turtle is keeping going on. This is the way to put infinite in code. Now another step, because you could say me, well, but we are drawing squares in a silly mad way. That's maybe funny, but it's silly and mad, but doesn't change much. Okay, let's make another step. I put here another variable, d side, which is, I mean delta side, a variation of side. And then I'm calling SQU 101. And then when inside procedure SQ, I call SQ itself, I give her the variable side, and there's a second variable, no, excuse me, pardon me, I give the first variable as first variable side minus d side and then d side. Oh, what's that? This is the way to draw a square spiral. Why? What's going on? Well, what's going on is that you are calling the first time SQU is 100 and a variation of the side of 1, and then when you drew the side and enter 90, you gave a side 100 minus 1, which is 90, and so on. Well, I introduced briefly the last constructor is the way the turtle can take these decisions. That is, you can let the turtle decide to stop by herself by after having drawn a side and turning, you say, please, my dear turtle, if side is less, say, than 20, then please stop. Now, let's go. And she stopped. Well, so, we are at 5 minutes from the formal end of the seminar, but as far as I know, we can push it the time a little bit further. At any rate, if I stop here, if you have questions in 5 minutes, it's okay. However, since we have another webinar, you can keep making questions, and please, I use this time and I will answer later. You have resources. First of all, you can write me email at this simple address, arf@unifi.it. It's University of Florence. This is my Twitter account, my Facebook account. But all this stuff is in a document on a server that you can download all this stuff. Please write down now the simple address https is.gd/stepback1. You will find the trace, what you have, or the trace of the presentation. You will find the PDF version. You will find the short text with the basic reason for making these seminars, and a manual in Italian still in Italian. I will try to have a translation in English sooner or later, but there's plenty of English examples and pictures, and you have a sandbox with the coding examples I showed you. So That's all. You have access from now to all these resources. And se trovo, okay, I go to see if you have questions. Okay, then maybe we are finished. I close the sharing. And if you have enjoyed this talk, we can meet again on Friday next week at the same time. Please write me freely if you have any kind of question. And ciao a tutti da Firenze. E grazie allo staff di Indire. Thanks to the Indire staff for the cooperation.
Thanks, Professor Formiconi, and thanks to all the participants, to my colleague Elena, and also to Assi from the Central Support Service for helping us. So see you for the second part of this seminar on Friday 16th. Thank you. Bye.